Yo, Algebrainiacs! Welcome to the Johnson Kendro Video Hour.
But it's not an hour.
Yep, it's not an hour, but you wish it were, don't you? Alright, we're going to do some function operations. Alright, take a look at these first four things listed. Um, you have to be familiar with these both ways because they're going to list them either way in the book. So you got to realize that f plus g is just taking the f function and adding the g function to it. And then that just goes for subtraction, multiplication, and division also. All right, let's try some of these. So we've got two functions here, f of x and g of x. And we're going to find all four of the um, operations. And then at the end, we're going to find the domain. Domain means what is allowed to be put in for x.
Well, I think sometimes it's easier to think about what can't be put in for x. So the things you guys want to keep your eyes peeled for are denominators that have variables.
I know 0 can't go on the bottom,
Right.
so in this case x cannot be 0, but it can be everything else.
Right, so we want to keep our eyes peeled for x's in the denominators, and then maybe otherwise square roots with variables, because what can't we have under there?
We can't have negatives and get a real answer.
Yeah, so I think unless they have either of those two things, then their domains are going to be all real numbers.
All reals. And we get to write that fancy R.
Oh, yeah.
All reals.
Love that.
Cool. All right, let's check this one out. F plus g. So we're going to take the f function and add the g function to it. So it's just x plus 7 plus x squared plus 9x plus 14.
That seems pretty simple.
Yep, it is. So now we add our like terms. I'm going to start with x squared, and then I have 9x and x is 10x, and then I have 14 and 7 is 21. So
that's the resulting function.
Now we have to figure out the domain. So what values of x are legally allowed to be put in there? Well, I can put positives, I can put negatives, and I can get 0 in there, so they all work. Fractions and everything. So the domain is the reals.
Cool.
All right, f minus g. So same process, x plus 7 minus. Now be careful here. Using parentheses to remind myself I have to distribute that like a -1 to all three of these. So it's x plus 7 minus x squared minus 9x minus 14. So x squared comes first. Then I have x minus 9x is minus 8x. And then I have 7 minus 14 is minus 7. Again, I can put anything in for x and it will come up with the real answer. So I can say domain is the reals.
All right.
All right, multiplication. All right, x plus 7 times x squared plus 9x plus 14. All right, we're going to have to distribute. Take the x, multiply it by everything in this other parentheses. So x cubed plus 9x squared plus 14x. Now I'm going to take the 7, do the same thing. 7x squared plus 63x plus, what's 7 times 14?
We know that, 343.
343.
No, it's not. Just kidding. That would be 7 times 49.
All right. 14 times 7 is 98.
I was just checking to see if you were paying attention.
Okay. I almost fell for it. Not quite. All right, put like terms together. We have an x cubed. I have 9 and 7, that's 16x squared. I have 14 and 63, that's 77x. And then just a plain old 98 at the end.
And the domain.
Domain, again, we don't have any fractions, or we don't have any square roots, so it's going to be the real numbers. All right, dividing. So I have x plus 7 over x squared plus 9x plus 14. Can we cancel these x's?
Not right now.
No. Can we do heart surgery?
Nope.
Nope. So
we're done.
No, you wish. So x plus 7 is fine. Now this is actually a quadratic, so we should be able to factor it into two parentheses. And once you do that, then hopefully something will cancel out. the x squared is x and x. 14 is either 14 and 1 or 7 and 2. Which one will get us 9?
7 and 2.
All right, let's use it.
And pluses.
Everything's plus. Now I see that these two are identical. It's multiplication, so I'm allowed to cancel. So is my answer just x plus 2?
No, it's a fraction and x plus 2 is on the bottom, so 1 over x plus 2.
This turns into a 1. Now we have a little problem with our domain. The only thing that this can't be is 0. So what's going to make that 0? The only thing that will make that 0 is x equals negative 2. Now, that's one of the answers. Back here at
And that's
one
an
time,
answer of what it can't be.
right. Sorry. Can't be. We'll put a do. Do not be 2.
Do not be.
So now we have x plus 7 also was in the original problem, so we have to include that one too. So x cannot be negative 7.
So it's all real numbers.
Right, so we can say domain x is the reals, except x cannot be negative 2 or negative 7.
That's kind of tricky because, first of all, the division part was tricky, and then we have to consider something when we're simplifying or when we're finding the domain that isn't even in the answer anymore.
Right.
It was in there at one time.
Yep, so you want to go with the original problem before you simplify to figure out the domain restrictions.
And that's only going to happen on division, right?
Right, because that's when x can't be 0.
Okay. All right, also part of function operations are composite functions. And we got some hints up here. Always start on the inside and work back out. So this is not multiplication, and it's not GOF.
Goff. Backwards would be fog.
Fog or
Maybe
GOF.
we're all in a fog when we're looking at these, but
What this really means, it's called a composite function. So notice that f of x is closest. That's what we should be doing first. So f of x, and you do that answer, you do that function first, you get an answer, and then you go and plug it into the outer one. So I like to be visual here. So let me show you my little diagram. All right. So
hey, nice drawings over there.
thank you.
That top one looks a little like the United States with like British Columbia, Canada drawn as an extra. Are we going to add that to our country?
It's a machine.
Oh,
It's the function
the
machine.
function machine. Okay, let's hear
I'm
about it.
trying to be visual here.
All right,
Okay, so when you see GOF,
Goff.
that really means that we're doing g of f of x. And the thing that we're substituting is the negative 3. So f of minus 3. We're going to do that first. When you see f of minus 3, it means that we're using negative 3 as an input into f of x. So look back to the equation that we had. If we plug in a negative 3 and subtract 5, what do we get?
Negative 8.
That is the output from this machine.
All right.
That becomes the input into the G machine.
Cool.
So then it goes through and all the math happens in there. And this time g of x is x squared, so we're just doing negative 8 squared. And what's the output from that?
Negative 8 squared is 64.
Positive 64. And whatever your final output is your answer to your question. Okay, the negative 8 is just a little step in between. But the final answer is
So you
the final
find the
output.
answer for the one and put that into the other.
Right.
Let's do it one more time.
Now what about fog? Does that mean that we'll get the same answer?
Probably not, since we're doing the x squared first.
Right, so the g is closest, so that means that we need to find g of negative 3 and get an answer, and then take that and plug it in for f. So g of negative 3 means go to the x squared and substitute the 3 and we get a 9. And that becomes the input into the f function. So the final answer is f of 9, which means substitute a 9 right there. 9 minus 5 gets us 4, so final answer is 4.
Oh, well, those are kind of cool.
And if you draw your United States machines, then you get bonus points.
Very cool.
That's not true, actually. I made that up, but
Just like this isn't an hour.
right, same thing.
All right, well, that's it for now. We'll see you later.